have a question. Now, I want real answers, not the fake answers that you like tell your friends because you want to seem cool. But really, who here has ever used an actual paper map? Like you had to unfold it, you could physically write on it, you can't drop pins on it. It's a real map. Like this. Ooh. Wow.
On my trip to South Carolina.
Nice. So you guys probably had an atlas too, because you had to have different states. So when you go to use the map, what's one thing that we know about how maps are designed? Like, why do I know that I can look at this and find things on it and trust it, Anthony? Okay, it's like a picture of it, essentially. So some maps these days are literally from satellites, but before we had satellites, we just had, like, drawings. Abby? Yeah, like coordinates on here. So if I look at, let's say, which county would you go? No, Dublin's not a county. You guys gotta understand counties are different. So, if you've never, okay, Franklin County. So, Franklin County, I'm gonna hang this back up here so you guys can see this. Franklin County is what encompasses most of the Columbus area. And if we talk about Franklin County, that's right here in the middle, where all the colors and all the roads meet. I mean, Columbus is the capital. It's where the whole state comes together, essentially. And we can come over here to Coshocton. This is where I'm from. So this distance right here would be how far it is to get to Coshocton. What could I infer about that distance compared to if I want to go see the Indians play and I want to go up here to Cleveland? What would I know about my drive to Cleveland compared to my drive to Coshocton? Justin? Why would Cleveland take longer?
Well, from what I can tell, it's a bit farther away than Coshocton.
It's further away on the map, but so what?
There's like a scale of distance on the map.
There's a scale on the map that I know if I measure a distance and then I measure another distance and it's longer, that means it's got more miles. If it's got more inches on the map, it's got more miles in the real world because of a scale. So a scale drawing in a map is just a scale drawing. Any scale drawing is just an enlargement or a reduction of the actual values. So if I want to draw a boat, I'm probably not going to draw the boat the actual size of the boat. That would take a lot of paper. Instead, I set up a scale. And I can choose my scale to reference whichever direction I want it to. So I could say 1 inch is going to be equal to 15 feet. Or I could say 15 feet is going to be equal to 1 inch. Either way I set up my ratio or I set up my scale, it doesn't make a difference to start. But once I have that set up, everything else relies on how my scale was set up. So we can use it inches over feet or feet over inches. It doesn't make a difference to start. That then will determine everything else. So does anybody have a ruler? Like on them, like you can or grab a ruler or whatever. We need to measure this distance. So the American golden plovers are a type of bird. They migrate from Nova Scotia to South America. And we know that if you've ever heard the phrase how the crow flies, birds can fly in a straight line. We can't always travel in a straight line, so we assume they travel in a straight line, measure that for us, and we need an inches measurement, because my scale is 1 inch to 4,000 miles. Now, while Xavier's measuring that, I need everyone else to write your scale 1 inch over 400 miles, or you could write 400 miles over 1 inch. It doesn't make a difference yet. Almost 1 inch.
It was like just barely a little bit. Your ruler's seen some better days. So it's a little under. I'd probably say it's like 0.8 maybe. Well, what are those tick marks?
So we'll be nice to ourselves here. We'll be nice to ourselves. and just say, now normally we don't talk about inches in decimal values, but right now we'll go ahead and let it happen. Let's say that this is 0.8 of an inch when we measured it. It's about 8/10. And I want to know how many miles, or what is the actual distance. Can I help you guys with something? I mean, do you need a pencil or something? Okay. So I can figure out how I go from my 1, because when I start with 1, it's super easy. How do I go from 1 to 8/10? Colin?
Well, 4/5 of 1 is 0.8. So it could be like.
And you just said of. What's of tell you to do?
So that would be.
We could multiply just by 0.8. If I multiply by 0.8, because guys, this is 1. Whatever I multiply 1 by, I end up getting the other number, because 1 does nothing, so I just get the other number. So I have to do the same thing on bottom. So really, what I could have just done is to find my distance. I just do 400 times however many inches I had. And that distance comes out to be
320 miles.
Now here's the tricky part though. I made these notes. I changed the size of things. Do not trust this. This is right with the math that we did. But I changed the size of this map without paying attention to the scale. So you have to be careful, especially when you go online, to make sure that if I'm physically going to measure, like Xavier just actually measured, I need to make sure that nobody changed the size of the map. If I go to measure this map right here, by the way, what's the thing on the map that tells you all the info you need to know? Abby? The key. So in the key is your scale. So right here, and I'm actually going to highlight it while I'm thinking about it, you can come up here and check out the scale, and you guys could actually figure out the answers to some of those, like if I want to travel from here to there, how far is it? But right here is your scale, and it says 1 inch equals approximately 11 miles. So now, because I know that pictures can change sizes, if I knew the initial distance before I changed the size. So now here in the picture of Florida, I gave you the measured distance. Let's say we're looking at a map, and I put the ruler on here. I take a little picture of how far the ruler stretched. So we want to say, how far is this distance? Well, I need to figure out what each of those tick marks means, right? So let's count up our tick marks. Start at your 0, and then move, and then start counting. So the first tick mark after zeros are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So each of those tick marks is worth a 16th. So I have over 1. I have 1 and 1, 2, 3, 4 more tick marks. So I have 1 and 4 sixteenths. Could 1 and 4 sixteenths reduce to anything? Andrew? 1 and 1/4. So we really have 1 and 1/4 inches. When your scale references 1, like 1 inch equals 110 miles. All I have to do is take my inch amount and multiply by that scale factor. Just check this out. Stick with me for a minute. Please write what I wrote. I'm going to multiply this by the scale factor, but I want to get rid of inches, and I want to end up with miles as my answer. So if I want to get rid of inches, really I should think of this like a fraction. 1 and 1/4 over 1. It doesn't change anything. Where should I put inches in this conversion factor that I'm going to multiply by to get rid of it from my 1 and 1/4? Shane? I should put it in the bottom. which means that I have to put miles in the top. So I have 110 miles times 1 inch. Does anything happen in the denominator?
No.
1 times 1 is just 1. I end up with 1, which does nothing when it's in the denominator. 1 1/4 times 110. Well, since I have inches on bottom and inches on top now, these are going to cancel each other out. My answer is going to give me just miles. What's 110 times 1 1/4? Shane? Yeah, 137.5. So that distance between there then is 137.5 miles. Now, when we're setting up a proportion with our scale, which a proportion, remember, is a fraction equal to a fraction. Not a fraction times a fraction, fraction equal to a fraction. So when I'm setting up that proportion, I can start whichever way I want. But then that determines everything. So like here, sorry, this is what I wanted to notate here. Here, my multiplication, when I plug in for x, if I want to get rid of the feet in the denominator, what I plug in for x would have to be in feet. Here, what I plug in for x to get rid of the inches on bottom, what would my x need to be in here to get rid of inches? Izzy? It needs to be in inches. So, how you set up your constant of proportionality tells you what your input has to be. So if we have multiple labels here, you're trying to cancel out whatever you can. So we would be canceling out what's on bottom by multiplying by feet. That would destroy it, and we would end up with inches. So my answer here would be that y would equal some amount of inches. My answer over here would be that y would equal some amount of feet. So now flip to the back. We're looking at designing a billboard. We've been asked to make a billboard for the Manta Ray Bay Aquarium. Love a good aquarium. So we know that we have a scale of 1 inch to 1.5 feet. So we can set up 2 different equations depending on which I want to do. What are the values that I'm going to have to plug into my problem? What values do I have right now on my sign? Colin?
16 inches and 8 inches.
I have
Because 1
inch
inch
values.
equals to 1.5 feet.
Yeah, so since I have inch values to plug in, that tells me I want my x in inches. And to do my x in inches, that means that when I set up y equals something times x, should my inches be on top or bottom here? If I refer back to what we did there, trying to get rid of inches and get an answer in feet, I want my y value when I end to give me feet. And my x value is going to be my inches. So when I set up my constant of proportionality, Abby?
You put one of the numbers on the top and one on the bottom.
I agree. The question is which is which. If this will be inches plugging in for x, inches should go on bottom and feet should go on top. Really, you're thinking, what do I want my answer in? And that goes on top. So I want my answer in feet. Feet goes on top. So I have 1.5 feet is 1 inch. So now I can do y equals 1. Well, what's 1.5 over 1? It's just 1.5, really. So I could just write 1.5 feet per inch, but instead, let's look at why this math works. So my top is feet, my bottom is inches. I'm going to multiply by my x value. Do you want to do length or height first? Doesn't make a difference.
Like,
Let's do length, sure. So 16 inches, and I'm going to put that over 1. I have inches now on bottom, and in top, they'll cancel. What's 1.5 times 16? 24. Label would be feet. Do that on your own for the height. So we're going to use the same equation to do our height. Yeah, you can move on to the got it if you're ready. Joe, did you get a height for the sign? What'd you get?
Oh, no, I didn't.
Okay. Grace, did you get your height yet? So if I set up the same thing and I do 1.5 feet over 1 inch times 8 inches on top over 1 just to make it a fraction. I have inches on top and bottom, which is what I want, so they cancel. Justin, what do you get? We get 12 feet. So my sign would end up being 24 feet by 12 feet. Which actually, since we know that we're using the same scale factor, I could have looked at 16 compared to 8. The height is half of the length. Once I knew the length, I could have just cut it in half to find the height. In your state driving book, which scary enough, some of you will be looking at sooner than you realize. Yeah, I've got students that are now driving. It makes me feel old. Your scale, in the book, your sign is 2 inches by 3 inches in the book. You're really bored at reading your driver stuff, so you measure it. You know that the scale to compare to the real would be 1 inch to half a foot. Like every inch is equal to half a foot. We've done the equation method, which is actually more difficult than what we need to do. Because I have a reference of 1 inch, all I really have to do is say how many inches times my scale factor, because that denominator of 1 inch, it doesn't do anything. So really, to find my feet here, I could just say that my y will equal 0.5 times the 2, because that's my scale factor of feet per inch. And this is inches. So I end up with 1 foot. Do the height on your own, the height of that sign. Abby, what'd you get?
I got 1.5 feet.
Yep. 1.5 feet for the.
Just because I said 5 times 3 is 15. Just add that spot right in the middle.
Yep.
There you go. That's mine.
Now this next section goes both directions. So we start. Sorry, I'm ahead of myself. That was a lie. We wait until Kansas to go both directions. So, a tennis court is actually 36 feet wide. The scale drawing is 2.25 inches wide. The scale drawing is also 5 1/16 inches long. We're asked, what's the scale? So we essentially need to set up one of those. So many inches equals so many feet. But we like our scale to use 1 inch. So if I set up my inches 2 1/4 compared to my feet, 36 feet, leaving it in that ratio form, not that nice. We've got a mixed number compared to an integer. Abby, what could I do to my mixed number?
Can't you make 2 4 improper, just like 36?
So what is it improper?
Improper, it would be 9
9/4
fourths compared to 36 over 1.
compared to 36 over 1.
I think I'm doing.
Lily? Ah, this ratio is really division. I could just keep change flip and do 9/4 times 1 over 36. This can actually cross reduce.
Yes.
The 9 and the 36 can both be divided by 9. So this becomes a 1, this becomes a 4, and this all becomes 1/16. And since I started with inches over feet, I'll still end with inches over feet. So we know that 1 inch is equal to 16 feet. Now, if you didn't end up with a 1 in your numerator, we could just do whatever we need to do to turn that into a 1. So say this was a 3 over 90. Well, how do you turn 3 into 1? Divide by 3. So you would just do that to the top and the bottom. So now is what I'm talking about, going both directions. We have a scale drawing of Kansas. Kansas, and this is actually really, really close to the real size of Kansas. They round it a tiny bit, but this is like as accurate as we can get. Kansas is very square. It's very boring. So this drawing was made using a scale of 1 to 100. And I know it says below, but I put it beside. Get over it. That map's not below anymore. We're breaking rules. You don't have to, but I'm doing that so you know it was using that scale. We are asked to make a new drawing. Say Pettigrew asks you, I need a new scale drawing, but I need to use a different scale. I need you to use the scale of 2 centimeters equals 125 miles. So the first thing we need to do is find out what are the actual dimensions of Kansas. Then we need to find out what our dimensions of Kansas will be. How can I figure out the actual dimensions of Kansas here? Bella, do you know? If I know that every centimeter equals 100 miles, I've got 2.1 centimeters here, 4 centimeters there. Is either of these real easy to solve? Ooh, 1's a decimal, but 1 isn't a decimal. I could. You're right. No, I mean, we could. We don't have to, but that's one option we could take. If I know 1 centimeter, every centimeter is 100 miles. How long would 2 centimeters be? 200 miles. So what about 2.1 centimeters? It'd be 210. All we really have to do is take our 2.1 centimeters. Guys, like I said, since it references 1 centimeter, you can just multiply by your conversion factor. And that gives you, this was actually 210 miles. Same thing with my 4 centimeters. I can multiply that, and I get that Kansas is actually 400 miles wide. Okay, guys, this is like, we looked up the real dimensions of Kansas, and it was like 213 by 405, or something like this is as close as we can get. So we solved out the real dimensions using that nice, simple conversion factor. But now our conversion factors changed. Now our conversion factor is that 2 centimeters will equal 125 miles. So I want to figure out on my map, what will the dimensions be? So I'm going to go ahead and cross out the 2.1 and cross out the 4, because those are no longer going to be the dimensions. So set up your scale factor. I have 2 centimeters compared to 125. And guys, with all of these, there's a lot of different ways you can solve this. We could use an equation right now. We could reduce this down to 1 centimeter and then use it that way. But I'm trying to show you various ways to solve these things. So then, what am I going to be using? Am I going to be using centimeters or am I going to be using miles? Like, what do I know right now? Case, is that a hand or no? Abby? Yeah, I know the actual miles. So if I set up 210 miles here, then I don't know how many centimeters. So I can just plug in some variable that I don't know. Now this is where the cross multiplication comes in super handy. We want to cross multiply and set those values equal. So we have 125 times x equal to the other cross multiplication of 2 times 210. That gives me 125x equals 420. How do I get the x by itself? And to answer that, you first ask, how is it attached? So Hayden, what is attached to x and how right now? Yep. How is it attached? Yeah, but what operation? Add, subtract, multiply, divide. What's holding it together? Multiplication, right? So how do I undo that? We divide. So I know I'm going to have to divide. Now what am I trying to get rid of? Abby? So that's what we divide by. Anybody have it?
Wait.
3.36, I believe so. So your map would be 3.36 centimeters tall. The map that you are drawing. I'm going to do this same exact process. But what am I going to change in my original proportion setup? If this ever comes back, I hope it does. There we go. Justin, what am I going to change?
Isn't it set up,
So in this original setup over here, to solve for the length on my map, all I would need to change is the miles. So if I change my miles to 400 instead of the 210, now my cross multiplication, my green is 2 times 400. My blue is 125 times x. So again, I multiply these guys, I get 800 equal to 125x. And the last thing I need to do, and you guys are going to be pros by the time we get to equations, to undo a multiplication, we want to divide, and we just do it on both sides. What do we get? What, Shane? 6.4. I've heard 2 different answers. Can anyone verify either of those?
Oh, it's 125.
6.4. So my map then, right here, I need to really slide all this stuff down. Ooh, most of it. This will be 6.4 centimeters. So my scale is going to end up making the map a little bit bigger, but that's okay. Any questions on how we set up that proportion or how we cross multiply? Now's the time to ask. If you are wondering, I guarantee half the class is wondering. Abs.
So,
There are no stupid
and I
questions.
have very bad sound.
She said it would have been a stupid question. I said there are no stupid questions.
If you ask what the
There's silly questions that don't need asked, but there, if it's on topic, there's no stupid questions.
I was gonna ask, so, like, could you, like, convert those and find the whole dimension of it?
What do you mean? You mean the real or the map dimension?
Like, what I meant was, like, can you, like, have, like, one number, but that equals, like, the whole, like, is this, like, the perimeter of Kansas?
So this is the height, this is the length. So if I wanted to find the perimeter, I would set up the other height and the other length. But these two sides are like perfectly straight. This, the top and the right side, they have a little bit chopped out of the corner up here, so that'd be a little bit more difficult. But if you look up the real dimensions of Kansas, it's like 213 by 405 or something like very close to our actual math right here. So let's try this in the Got It. You're planning a neighborhood. And you are going to put a rectangular building as part of this neighborhood. So right now, your friend made this scale drawing. And you're like, dude, you did it wrong. So your friend's like, screw you, I'm not doing it again. I mean, that's most of my friends, when I tell them that they did it wrong, they're like, well, fine, you do it. So now we have to do it. Now the problem is, we don't know what the real dimensions of the building are supposed to be. So we first have to take his drawing and his scale factor.
Why do they always use one dimension? Like, one for one.
Now, so how I set this up, my story is not quite syncing up with theirs. But the original scale factor was 2 to 75. It says that you used it. I'm telling you that your friend used it. Regardless, that's how they got these dimensions of 6 and 8. So we need to figure out the real dimensions. Now with this scale factor of 2 to 75, could I get it to a scale factor involving 1 inch to something? Yeah, how could I do that? Got like the same 3 hands all class.
Hey.
Actually 4. Xavier, do you know how I could turn my 2 inches into a 1 inch?
Divide.
By? Yeah, so if I divide by 2 there, I can divide by 2 here. Now this gets a little bit messy, but if this is another technique that we can use to solve these. So now I could say 1 inch would be, well, what's half of 75? Break it apart. What's half of 70? So that'd be 35. Half of 5 is another 2.5. So this is 37.5 feet. This is the same scale factor, just represented differently. This is the same scale factor, just using different numbers. So now that I've got a 1 inch representation, what do I do to figure out the real dimension of the 6 inch side? You've talked to Jaheim. What do I do now that I've got a 1 inch reference to figure out how long the actual 6 inch side is? What do I do using that 6 and my scale factor? If every inch is 37.5, what would I do if it was 2 inches long? So So if I went from 1 inches to 2 inches, how's that change work? What would I multiply to go from 1 inch to 2 inch? You can always pass this off if you want. But if you want to keep working it, we can keep working it. So I think it'll be easier if I set it up. And actually, you might see this, Jaheen, once I do this. We have our scale factor of 1 inch is 37.5 feet. We're trying to solve how long is 6 inches. So who'd you pass that to? Did you pick someone? Abby, what do I need to do to figure out the actual dimension?
So if you were multiplying it by 1, once you multiply 37.5, wouldn't that be multiplied by 6?
Yeah. How do I go from my scale factor to my dimension that I have? I do multiplication by, 6. How do I go from my scale factor to what I have? I do multiplication by 6. Now the other thing we could have done here, we could have used this 2 inches to 75. If I was going to set it up like this would have been perfectly fine. So either of these can be used, but if I do times 6, what do I get here? 225 even?
Yes, 225, yes.
So my real dimension is 225 feet. Now I can do this again, but instead of a dimension of 6 inches, we now have a dimension of 8. So what do?
37.5 times 8.
Take your conversion factor and just multiply it by how many inches.
I'll get it.
So I'm going to get 225 plus another 75.
So 300.
This is going to be 300 feet.
300 even.
So now that we know all of that, we know 225 by 300. I now need to use those values, and my new scale factor of an inch equals 100 feet. So now we're trying to solve for some inch values. So we can cross this guy out and cross this guy out if we want. Now I use my scale factor of 1 inch is 100 feet. And now I have, let's do the easy one first. If I have my 300 feet across the bottom, how many inches will that be? What happens in my ratio? 3 inches, right? Because we multiply by 3, so that's going to be 3 inches. Now what if I do, instead of 300, the 225? That would have to multiply, Anthony.
It's by 2 1/4.
Yeah, by 2 1/4 or 2.25. So how many inches?
2 1/4.
Yeah, 2 1/4 inches, which, because it's inches, I'm going to go ahead and write that as a fraction. We are going to skip that final. Got it? Tomorrow, now hold up. I need your eyes for a second. There are some of you that have not submitted a single homework in Chapter 2. I know who you are. I'm not calling you out directly because that's rude, but I looked at the grades this morning. I know who hasn't done a single homework, or at least submitted it. Some of you, on the flip side, have done everything all up through 2-4. So tomorrow is going to be a work day, but if you have not even submitted 2-1, do not think that you're going to catch up tomorrow. So you need to, tonight, get as much practice done as you can, because ideally, tomorrow you can already work on 2-6. Like, you can go ahead and work on it if you are done with all the other ones. So tomorrow, you could get done with all of your Chapter 2 practice and be ready for the mastery. Tomorrow's a work day. Come ready to work. Bring your math notebook with you. Bring your calculator if you want it. No one's leaving my class once we get here. We're working the whole time. Okay? Have a great day, guys.
Time 24 and 7. Accelerated 7 over.
You're going to take the test tomorrow, actually.